All right, we'll start. Okay, before we start with the lecture, we're nearing the end of the term, so I just want to raise some logistical issues. So your assignment will be due today or Friday, depending on your slip day. Next week is the last class, so your projects are due the last class, and the week after that is the final exam. So it's basically assignment, project, final exam. So everything's pretty tight. For the final projects, does anyone want more time? Yeah. So I can accept it a little bit later for sure. Usually students are asking already, but you guys seem very polite and don't want to ask. So the tricky bit is there are some students who will be graduating this term. It will be your last term. And so I'll need your projects a bit earlier because we want to get your marks in right away. And so what I'll do is I'll give you an extension that will be twofold. So let's see. Okay, so instead of, so December 4th would be the Monday before the exam. If you have a member of your team, at least one that is graduating this term, it's your last term, you have to hand it in by December 4th. Okay? And if you do not, if your whole team has another term, you have more courses, you're still in progress at the end of this term, then you can hand it in Friday the 8th, so that would be 2 days after the exam. So the exam will be on Wednesday, and then you'll have Thursday, Friday to work on. Okay? Everyone's happy? Yes, okay. Now, with that said, another thing is there are course evaluations. So you probably got a lot of emails about this. So please do them. I read them. A lot of comments that people have made, like, for example, why do I record my lectures and put them on YouTube? Because someone made that suggestion a long time ago, right? And so I did it. Why do we have slides? Before I used to handwrite things out. Well, someone made a suggestion and I did it. So I do actually listen to the feedback, and if it's a reasonable suggestion and I actually think it would improve the course, I'll do it. So you can tell me whatever, if you like the lectures, do you like the slides, do you like the assignments, are they useful, are they too hard, are they too easy, all that type of stuff. And if you want to just fill out the survey, it's a Likert scale, so you all know what that is now. But just remember that a 1 is good. So normally 5 is like good, but in this case, 1 is good. So every year there's a couple students that are like 5, 5, 5, 5, 5, 5. And I don't know if they hate it, like they just hate everything, or they're just like, they're not paying attention. But anyways, that happens. Okay. And then I think the room number for the exam is not posted. They're doing it differently this year. So it just has the time. You're actually split between 2 rooms. And so I'll figure it out by next week, and then I'll put on the Moodle what room to go to. Usually it's just based on last name. If your last name is between this and this, then go to this room. Otherwise, go to the other room. The exam itself, I'll talk about next class, but is there any questions? Usually people are pretty anxious about it. So generally, in terms of format, it will be some short answer questions and a lot of multiple choice questions. Like mostly, when I say a lot, I mean as a percentage of the exam. The exam shouldn't be super long. Usually the fastest students might finish within like short of an hour, like maybe 45 or 50 minutes. But then there's some students that will stay for the full 3 hours or whatever. And so you can use the whole slot. You'll have the whole slot available for you. But I don't think you're going to find it to be the kind of exam where, it's 2.5 hours and you still haven't answered half of the exam or something like that. It's probably one where you can get through all the questions and then have lots of time to think about the questions that you skipped over. The questions will be conceptual. So like it will be sort of asking you new things using the things that we talked about in class. Yeah, okay. And then the other thing, I don't know if I probably mentioned at the start of the class, but you can bring a sheet of paper, 8.5 by 11. you can bring it with whatever you want written down on it. Okay, so no question is going to be a straight memorization. It's not going to be like what does stride stand for or something like that. So anything that you're worried about not remembering, just put it down on your sheet of paper. And yeah, my goal is always that you spend a lot of time making that piece of paper. You kind of learn the content of the course by making it, and then you never look at it in the exam itself. But so that's the things that come to me at the top of my head. Is there any questions or anything else? Short of like, what are the questions? I'll answer any questions you have. But. Oh, another thing too that I reminded, the multiple choice will be on a Scantron form. So I'll give you a Scantron form. So you have to bring a pencil. Even black pen, it doesn't always scan right. So bring a pencil, and I'll have extra pencils if you forget. So it's not a big deal if you forget. But yeah, so pencil, Scantron form, and short answer, multiple choice. I think in past years I did about, I don't know. I feel like it was maybe around 30 multiple choice and 4 short answers or something like that, kind of. So I don't know. I don't remember exactly, but yeah. And it's really heavy on the concepts. Okay, so like students that find it easy really understand the material, and the answer isn't really in the material. It's about whether you understand it. Like that's where the answers are. So in terms of studying, it's just like go through the lectures, and any time where you're like, I didn't really understand that. Like they went through an example and I didn't really get it. That's where you spend the time. Just take the time to understand it. Once you understand it, move on. There's nothing to like commit to memory. Like I say, you can just write it down if you're worried about forgetting it during the exam. And yeah, it's just really making sure that you understand the concepts. All good? Okay. Okay, is there any questions about last class or anything else before we jump in? Okay, so we're going to continue our discussion of security policies. So last class first off, I gave you a bunch of just short examples of what policies are. We looked at airports, that's a big policy. Airports is something that involves real human beings. It involves lots of different organizations and things like that. For the next 2 lectures, we're going to narrow it to more of a technical focus. And so we're going to look at 2 policies that are in browsers. One of them concerns cookies, and one of them concerns what are called origins, which I'll explain next class. So the policy that corresponds to origins is called the same origin policy. The policy that corresponds to cookies is the cookie policy. There is some overlap. So they both consider this notion actually of origins. It's relevant to both of them. But the policies are about different things. One's about cookies, one's about mainly like JavaScript and things like that. And there's a lot of attacks that you either have already learned about in 6.130, I think, or you will if you take that course. And so things like cross-site scripting, cross-site request forgery, and things like that. So we're going to go over that again in this class. But in this class, the emphasis will be a little different. It's less on like the attack itself, and it's more about like, why did the policy lead to this attack? And if you changed the policy and did something different, would it solve the attack or not? And is there a different sensible policy that you could use and things like that? And so you'll see that the features that you want from websites and these attacks, they kind of go hand in hand. You can't kind of pick and choose. Like if you want websites to work the way that you want them to work, then you're going to leave yourself open to attacks because it's hard to like write down these policies and get them exactly correct. Okay. Okay, so browser policies are implemented. First off, who decides a browser policy? Okay, so how do cookies work in a browser? It's the browser manufacturers. So they originally decided these policies. And then there's an internet working group where a lot of people who work at browsers and other tech companies, they come together called the IETF, and they'll work out standards and things now. So now it's more of an open collaborative process. And of course, a browser can choose not to implement the standards that are decided. I mean, browsers have free reign. They can do whatever they want. They're giving a commercial product. But generally, browsers want not to break the web. And if web developers are doing things a certain way, they want to do it in the same way, just to make sure that there's maximum compatibility. Okay, so more or less all browsers kind of look the same. So your early internet browsers were things like www, Mosaic. These were like very early things. Netscape Navigator was basically the first mainstream browser that a lot of people used. Then Microsoft saw it as very critical. And so everyone was using Windows, but they were running Netscape Navigator. And so Microsoft said, hey, we have all these Windows users. Can we get them to use our own browser? So then they came out with Internet Explorer. They actually made it the default in Windows. Then they were sued because the government actually stepped in and said, you're not allowed to do that. You have, you have these browsers. You have a monopoly basically on operating systems. You can't use that to bully people into using your browser. And anyways, that ended up being a whole thing. Then Apple came out. Firefox was another independent browser. And then Google Chrome in 2008. And then you can see the sort of breakdown of who uses what today. Just give me one sec. Okay, so the policies that we're going to talk about concerning cookies and same origin policy, it was Netscape that really worked them out. Okay, so Netscape were the ones that came out with it. So in '94, when Netscape was the dominant browser, they came out with a cookie policy. And then tomorrow we'll talk about the same origin policy, which was in '95, the same year that Internet Explorer came out. Once these two policies were set by Netscape, basically everyone followed suit. So Internet Explorer did what Netscape was doing, and then all your later browsers just copied it because people didn't want to, do things differently. Okay, so this is a sort of breakdown of something that will be important. So both of these policies concern what we think of as web resources. So if you download a website, what you're getting are kind of like a set of resources, okay? So a resource could be something like the HTML page that you're getting. But then if there's an image that's in the page, that's a separate resource. So the image is a resource. If there's JavaScript that you're supposed to run, that comes down, that's also a resource, okay? So resources are sort of the abstraction that we'll use, okay? And resources can be either in the website itself, or they can kind of be in the header fields of the website, okay? So think of an envelope, and when you download stuff, there's stuff that's inside the envelope, and there's stuff that's written on the outside of the envelope, okay? So meta content would be things that are sort of on the outside. So they're not part of the website itself, but they're sent, when you send requests and you get responses back, they go along for the ride, okay? So cookies, which we will talk about today, they're an example of meta content, okay? So there's no cookie in the website itself. It's just something that's in the messages that are going back and forth. Other things would be like, what browser am I using? My browser will tell the website, oh, I'm using Safari version whatever. So then the website might show me a different version of the website than if I was using Chrome or something like that, okay? So that's a string. It's inserted by my browser and it's put in the header of it. Also, like if I click on a link, so I get to the website by another link, then I might send along what was the link that referred me to the website. That's another example of things. And there's a million of them. These are three of them, okay? Then there's the stuff that are in the website itself. So these are like images, fonts, styles, JavaScript, audio, video, that type of thing. And what we tend to do is we tend to break them into two categories. So there's things that you just look at that don't run code, okay? So HTML, you just look at it. A video, you look at it. Audio, you look at it or listen to it. So we call that passive content. And then there's things that run code, okay? Arbitrary code. So JavaScript would be an example. Style sheets should be something that you just look at. That sort of defines the layout. But the language that you use to specify a style sheet has gotten more powerful over time. And so now it's not trusted anymore. People consider it to be capable of executing code. And then there's things like once you have JavaScript running, it could open up a connection to a server and ask for resources and things like that. So that's what XML HTTP request is. It's a separate way of requesting resources through JavaScript rather than the browser initiating the request. Okay. So anyway, so all of these things will become relevant today and next week. So right now, for now, I just want to note, because we're talking about cookies, that that's where the cookies are. They're outside the packet. And then next class, when we talk about same origin policy, the difference between passive and active will be very, very relevant. Okay. Now we have seen this before. Okay. The one place that we saw this before is with HTTPS. So if I download a website and some content is coming over HTTPS and some content isn't, do I show the lock or not? And the answer is, well, is it passive or active content? Okay. So generally, if it's active content, it's now blocked. So like you won't download it. The browsers will reject it. If it's passive content and it doesn't come down over HTTPS, then you would get like a warning from the browser, like a mixed content warning, that type of thing. And all the different iterations we looked at when we looked at that before. Okay, so what are the security goals at a high level for a browser? So a browser is going to implement some decisions about when are you allowed to use cookies, who's allowed to use them, who's allowed to see them, who's allowed to set them, who's allowed to change them, who's allowed to run JavaScript, or does the JavaScript run in this context, that context, blah, 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 okay? All of this stuff has to have an end goal. So what's the end goal? And so basically what you want to prevent are tampering attacks. So if the web designer, the person designing the website, they have something they want the user to see, okay? So these policies should help the user see exactly that. If someone can step in and change it and make it look completely different, then that would be a failure of the policy. Privacy is another one, okay? So if I'm putting a password into one website, another website that I have open shouldn't be able to read that password. That's a pretty obvious one, okay? Or a credit card number, things like that. And so there's all sorts of information, like if I log into an account and it's displaying personal information, like my banking information, then other websites shouldn't be able to see it and things like that, okay? So that's another axiom of browser policies. Okay, now just let's bring us to the actual topic at hand. So here's a little thought experiment, okay? So I go to Gmail and it says, you need to log in. So say it's a brand new computer, never used it, turn it on for the first time. I go to Gmail, I log in, okay? And so that's fine. It's successful. So now I'm on a website and it shows my inbox, okay? And I click on the first message, okay? So I want to see the first message in my inbox. Do I have to log in again to see that first message? Okay, so how does it know that I'm the same person that just logged in? Okay, session, authentication token, any other guesses? We'll go through these one by one. I'll solicit all guesses first, and then we can go through them. Say it loud. I didn't hear so. Cookies, yeah, sorry. Okay. Any other ideas? Okay, so these are all guesses. Actually, all three are correct, and they actually are all the exact same thing, okay, which we'll see. But first, let's sort of disavow like a couple ways that you might think. Maybe you're too shy to say. Could it be based on IP address? You see this person, they come from this IP address, they log in, then you see, give me my first message from the same IP address. Why not? Okay, so spoofing would be hard because you have to set up a three-way handshake, but could multiple users be on the same IP address? Absolutely, right? Especially with NAT routing like we have in Concordia and things like that. There's going to be lots of users from the same IP address, okay? How about IP plus port? Okay, so IP plus port is how routers work to figure out who all the people are that are using it. That's something that exists between the user and the router. Okay, so it's something that the router and the user see, they negotiate. But from the router to the website, it has to actually put it over the port, like the HTTP port, in order to reach it, or HTTPS. So the website won't see the port. The website actually doesn't know you're using that router or anything like that. So that approach also doesn't work. Okay, so cookie session IDs, tokens. So how does that solve the problem? What are they? How do they work?
So when you first log in,
Yeah.
It provides you with an authentication token that you store it.
So who? You said it provides you.
You store it in the browser.
But who provides it?
The
browser? The browser or Gmail?
Gmail.
Okay.
It provides the token, which you save it in your browser.
And what's a token? Like a crypto key or something?
It can be an hash or something like that.
A hash of what?
Depends on the application itself.
Okay. But what would be like would it be like a string, like ABCD? Your name?
Kind of like a string.
Okay. I'm not expecting you to know all the answers. I'm just teasing you a bit. But yeah.
Application, but usually it's a string.
Okay.
The
Okay.
application provides, and each time you make a request, you send the string along with the request, so it verifies it's you. And
Okay. There's a lot of its and yous, so just who's it and you. So
so the application, each time you, as a user, you request something from the application.
yeah.
You pass along the string. And
Okay.
the application verifies if it's actually an authenticated user, and it checks all sorts of things like timing and blah blah blah. When the authentication token was issued and all sorts of things, and then it allows if it's legit or.
Okay. So let's accept all of that. Well, that's true. Okay. We've accepted your explanation. Answer the question then. How does that keep me logged in?
Since only you have access to the authentication token, so basically each time you request something, you are providing the proof that you are who you say you are, and then accessing the resources.
Okay. So what I heard from you is that Gmail gives me a number or a value or something like that. And every time I go back to Gmail, I send that value. And Gmail looks at the value and says, yes, that's your value, so I know who you are.
That's how most of the applications work, but I'm not sure about Gmail.
Yeah, sure. So in general, yeah. And so that is actually more or less the story, okay? Now, there's two caveats. So one is it needs to be unique, obviously, right? And the second thing is, well, what if I put in your value for me? So I'm going to Gmail, I put in your value instead of my value. Then what happens?
It should check for other things.
Okay, sure.
Session ID and blah, blah, blah.
I do it from Concordia at the same time. You just did it like 3 seconds ago. We have the same IP address. It's at the same time. Literally everything looks, there's probably no way for Gmail to distinguish it's not you.
Then it should allow it.
Yeah, and so it does, okay? So if I steal your authentication token and I send it with my request to Gmail, then boom, I'm logged in as you, okay? So that's what we call session hijacking. So if you've heard the term session hijacking, it's exactly that. It's just I steal your cookie value, I put it in my requests. Smart websites will like look at IP address and they'll try and use some other information. If something looks like suspicious about it, then they might reject it or they might force you to put your password in again. But if it looks okay and looks reasonable, then they'll just accept it. And you can control that yourself by like not clicking the keep me sign in button and things like that so that your sessions eventually expire. But even if I do it within your session, then I can still do it. Okay, so that's session hijacking. So another important component of a cookie is it's unique and it can't be guessed. If it's too short, if it's my name, right, well, you can guess my name, or if it's my email address or something like that. Okay, so you shouldn't be able to guess it. So it's basically a password. You can think of it like a password. It's just a password that the server is assigning to you rather than you choosing it for yourself. Okay. I'm going to show you a video. This is just a sort of fun video that I'm just going to plug in because there's sound. This is more about like why cookies go bad. But anyways, this is something Concordia made. I'm in it. And then I'll go through the details of how actually cookies work. Okay, we'll see if the sound works. Most of us think of Google as a search engine, but it's also an ad agency. Hi there, I'm Jeremy Clark, a professor at the Concordia Institute for Information Systems Engineering. Today we're going to demystify internet cookies. So all of you have certainly heard about the delicious types of cookies, and most of you have heard about internet cookies. To help understand this concept, I'm going to tell you a little story about Alice. So let's say that Alice gets a brand new tablet. She opens the box, turns it on for the very first time. At this point, she's completely anonymous. She decides she wants to go and find some books to buy. So she goes over to Google, and at this point, a cookie's born. Think of a cookie as a serial number that websites assign to their users to track them around their platform. As Alice looks through her search result, she notices a pair of boots from her favorite shoe store and clicks on the link. By default, a cookie from one website can't follow you onto another website. However, Alice's favorite shoe company, like most of the top million websites, has a business relationship with Google. This allows Google's cookie to follow Alice through the virtual doors of the shoe store, like a little digital stalker. Alice gets bored of looking for boots, so she decides to go over to a message board to chat about her favorite show, Black Mirror. On the message board, she sees an ad for the exact boots she was just looking at. So what's going on here? Most of us think of Google as a search engine, but it's also an ad agency. The chat room in this case has outsourced its ads to Google. And because Google has a cookie that followed Alice from the search page to the shoe site and now to the message board, it knows exactly what ads it can serve to Alice that she's likely to click on. Using cookies in this way is prevalent on the modern web. Of the million most popular websites, Google can trace you across about 50 to 80% of them, while Facebook can track you across a third. Now, all of this may sound very scary. You should know that cookies are primarily used for advertising. However, there are more nefarious uses. For example, websites have started selling digital dossiers to political campaigns for micro-targeting. Now, you may be wondering what you can do to stop this. The truth is, it's pretty much impossible to live a cookie-free existence, as cookies also serve practical functions that make the web easier to use. However, there are some small tweaks you can make to your browser settings to help protect your privacy. First, you should disable third-party cookies. Second, you should enable Do Not Track, which prevents companies that are compliant with Canadian law from using cookies to trace you. The third thing you might use is private browsing mode, which gives you a fresh identity, sort of like when Alice turned on her new tablet for the first time. This is why digital privacy is such an important issue moving forward. And that's how the cookie crumbles. All right.
Nice sweet.
Thanks. Okay. I had nothing to do with, I just wrote the script, but our animation department did all the hard work on it. Okay. So let's go through the theory of it. It's going to be sort of a repeat of what we've already established. So a cookie is basically just a number. It's a value. It can be a string or whatever, but it's just a piece of data. Okay, it's a bunch of bytes. Think of it as a number. And precisely, it's what we call a key-value pair. So key meaning the identifier, like session ID, SID, and then the actual session ID would be a number. So that's what a cookie would look like concretely, okay? So there's a name for it, and then there's the actual data itself. Yep.
Is cookie like a pass, or let's say you're using a computer and you close it, there's like hibernation, you just return and you continue doing what you do.
Yeah, so the cookies themselves have, there's basically, okay, so the question is sort of like, when does a cookie expire? Right?
Actually, I'm also thinking, is it related to like a pass? Let's say you have this your card.
Right, yeah, so it's not, okay, so there's two questions here. Okay, the first is it's automatically done. So you'll see it in a second, but your browser's going to do it. You're not going to know that it's happening, like it's totally invisible to you until you actually go and look. So on the assignment that you'll do today, that's like showing you what's happening behind the scenes kind of thing, yeah? But yeah, cookies are just doing it. And then the second question is like, if you close your laptop, does it go away or whatever? And
I'm trying to say, is the cookie like closing your laptop and resuming from where you just left?
oh, I see what you're saying. Yes, yeah. So it is, yeah. When they work and they persist, yes, that's it, yeah. So it's just like you can resume doing whatever wherever you left off.
Without it asking you, let's say, password or.
Exactly, yeah. So a cookie is how it maintains continuity. Like you were the person that was just looking at this particular thing. Yeah. Okay, cool. Okay, so the actual key, both the key and the value themselves are chosen by the website. So Gmail says, I want you to store you to the browser. So it talks to I go to Gmail. Gmail will create a message. It will put it in the header of the response, and it will say, it will instruct my browser to create a new cookie. The cookie will have this key, session ID, and it will have this value. Okay? Then what my browser will do is it will store it in a special place called the cookie jar. And so it will have all of these cookies. Okay. Now the idea is if I go back to Gmail, my browser is going to go through my cookie jar. It's going to say, do I have any cookies that are from this website? And if I do, it's going to grab them and it's going to throw them in the request in the header. Okay. And so the exact mechanics of that is going to be subject to some details. But yeah.
I have a question.
Yeah.
Let's say Alice is on the banking website, right, with a token that was assigned by the website, the banking app.
Yeah.
Let's say an attacker gets that token, and let's say Alice knows that an attacker has that token.
Yeah.
If she creates a new session, like going to the private browsing tab and she creates a new session,
Yeah.
does it stop the Alice token from being inactive while she's using her new token, or does the actual not allow her to use it?
Okay. So the question, I'll just repeat it, is I know that someone stole my cookie, and so I create a new session, I log in, let's say I get a new cookie back. Is the old one still valid or not valid? And so the control over this is all with the website. So it has nothing to do with the cookies or the browser or how cookies work. It's purely like how the website wants to treat it. So from the website's perspective, it will say, it's going to say, I want to set cookie A, and then we'll do a bunch of transfers with A. Then I see the user and they're like, hey, I'm logging in again. And then I realize that they're the same user. I give them cookie B. Now all of a sudden I get a new interaction that's with cookie A. So I might look at that and say, it looks like they have a phone and a computer, and their phone is B and their computer is A. And they were using their computer for a while, then they used their phone, now they're back on their computer. I'll just log them in. Okay? Or I might look at it and say, that looks like an attack, right? It looks like they were using A, then they switched to B, and then someone got a hold of A and they want to go back to A. And so as a website, I can't really tell those cases apart. So probably, I think for most websites, they would accept token, like session B wouldn't replace, it would just add to the number of active sessions. Now, what you could do is if you were logged in as A, most websites have an explicit sign out button. And when you click it, it tells the website, hey, don't let anyone use this cookie anymore. So if I know that my cookie is stolen, I would actually log in with the stolen cookie, then I would sign out. Then the website won't let me resume a session until I put in my password again. So assuming the adversary only got my cookie, not my password, that's what would happen. Does that make sense? Yeah. Okay, so what you do with cookies and things like that, a lot of it's in the control of the website. And the other thing is you don't see it as a user. I mean, I have no idea what Gmail's policies are and things like that, right? You can experiment with it to try and figure out what they're doing and reverse engineer it, but it's not transparent to the user. Okay. Okay, so the idea is that once the browser has this cookie, it stores it, and then in future interactions, it's going to send it along. But now we need a policy. This is where the policy kicks in. Okay, so when do I send the cookie or not? So I'm looking through the cookie jar, and let's say the cookie was set by mail.google.com and the user is going to images.google.com. They're both Google, so I should probably send it, right? But then again, they're totally different websites, so maybe I shouldn't send it, right? So these are the kinds of questions that a policy is going to address. Okay, so just to show you again, like sort of in more graphical form. So I go to mail.google.com. I go for the very first time. Never gone there before. So I send a request like, give me index.html. And what Google will do is it will create a session ID for me. Because it's the first time going there, I'm not logged in. And because I'm not logged in, it doesn't know who I am. So what it will do is it will just say, okay, I have this new user. I don't know who they are yet. Okay, maybe they'll log in the future. I'm going to create a new database entry, so it'll be the middle entry. And I'm going to give them this cookie value that I've never given anyone else before. It's just a random number, and it's really long, so like the chances that someone guesses it is really slim. Okay? And so yeah, it's called the session ID. It's unpredictable. It's unique and unpredictable. Okay, high entropy and unique. Then what they do is they say, okay, you asked for index.html, no problem, here it is. By the way, in the header, I'm going to instruct your browser to remember this cookie. Okay, so I'll set the cookie. The cookie will have value SID, and then the actual value of the cookie itself. Now, let's say that I'm visiting this website over HTTPS. Okay, we said that this cookie thing's in the header. That's sort of like, obviously everything that's in, like the response itself, that's going to definitely be covered by HTTPS, okay? What about headers of HTTP headers? Are they in the SSL envelope, or are they also on the outside of the SSL envelope? Any guesses? Let's say they're not. What would go wrong?
Anyone can.
Yeah. So they must be. So they are. They have to. If they weren't, then anyone could look at this. They would know what your cookie is. And getting your cookie is almost as good as getting your password, because I can take it and substitute it in, and I can log in to you. Why is it not quite as good as your password? If I gave you a choice, you could have my password or you could have my cookie. Why would you still want my password?
Cookies have time limits.
Okay. So they do expire eventually. So there is a time limit. And other things is websites usually, when you want to do administrative tasks like change your email or change your password, they'll force you to log in again. So right now we're sort of in a world where cookies will, like with just a cookie, if I show up with just a cookie, then they'll let me do a bunch of stuff with the website. But if I want to do really serious things, then they might force me to authenticate again, just to double check that I am who I am. Okay. So now Google is like, okay, I have this user, I don't know who it is. This is their cookie value. Yeah, okay, so this is just saying what we already said. So it is encrypted. Okay, this is a good place to bring up this story. So it turned out that actually, we mentioned this when we talked about SSL stripping attacks, but you have to kind of go back in time to this is 2010. This is how the web tended to work in 2010. What I would do is I would go to a website like Facebook, and I'd say I want to log in, and Facebook would say, here's an HTTPS website with a lock, log in. Okay, so once I type my username, I type my password, I hit log in. Okay, then what would happen is it would authenticate me, it would make sure I am who I am. Then it would flip me back to HTTP. So now I'm on Facebook and I'm browsing, I'm looking at my timeline, clicking on pictures, adding comments and all that type of stuff. But all that's happening over HTTP because the rationale was just that it was too expensive to serve up all this content over HTTPS and encrypt it. Okay, what goes wrong in that world?
Cookies are going to clear.
Okay, so the cookies are going in the clear. So I can't get your password. The HTTPS protects your password, but once you're logged in, then you're now just showing up with the cookie value, and the cookie value is going over clear text. Okay, so if I can get in the middle of your conversation, I can pull your cookie value out, and now I don't know your password, but I'm basically you. Okay. Now people realize this. Okay, but they said, well, you'd have to be like a black hat hacker to try and do this. Right, so it's a pretty sophisticated attack. Because you actually have to get in the middle. Okay, that's probably the hardest part. And then once you're in the middle, then you have to look at the raw packets and pull the values out and things like that. Okay, so then some engineer, we don't know who, I think they're anonymous. They said, you know what, this is actually pretty easy. If you're on Wi-Fi, then you can poison the Wi-Fi routing table and you can get everyone routed through you. So getting in the middle is actually like pretty trivial once you're on Wi-Fi. And then we can automate the rest, right? I can write a script that will pull the packet in. Once I see the packets going by, I can grab the cookie values, okay? So what they did is they created this like exploit tool, and they made it super user-friendly. They made it a browser extension. It was called Firesheep. And all you had to do was install it either from the web, or it might have been in the Firefox store, although I'm sure they took it out pretty quickly. And so you would just log in with this extension. So the user experience is I go to Starbucks, I connect to the Wi-Fi, I open up my browser, I click on Firesheep, and then it will just say, here's 5 people who are currently on Facebook right now in the cafe with you. And then I would double click on any one of them, and then boom, I'm into their account. Okay, I'm them, right? I'm browsing. So it was something that, like, even though the technology didn't change and this attack was always possible, something about bringing it, like making it so user-friendly, it really changed things. Then Facebook freaked out and Twitter freaked out, and the press, there was articles after articles about this. Then the government, got involved, and there were like hearings in Congress and the Senate and things like that about this stuff. And so it really went from this like fringe issue to like a mainstream issue. And then basically all the websites went HTTPS only all the time. So like within 2 weeks or something like this, Facebook, Twitter, all your major websites were using HTTPS. Okay, so let's go back to what's happening. So I've sent my request. I get the response back. It has a set cookie instruction. That's encrypted, so no one sees it. I decrypt it in my browser. My browser sees it. Okay, so my browser says, okay, I got to go set this cookie. That's fine. So it goes into my cookie jar, which is just a list of all the other cookies that I have, and it creates a new entry for this particular website. Okay. Then later, what will happen is, let's say I click on that first message in my inbox. I'm going back to the same domain, mail.google.com. So what my browser will do is it will say, okay, I see your request, I have it, it's ready to go, but let me do a quick check. Before I send it, let me go through the cookie jar and, oh, look, there's something that matches where you're going, okay? And so I'm just going to kind of throw that in as well, okay? So it puts it in the header, then everything gets encrypted, okay? So you can think of the request as inside an envelope, the cookie's written on the outside of an envelope, but then that entire envelope's put into the TLS envelope, okay? And then it's sent off to mail.google.com. They get the requests. Mail.google.com looks at it and says, okay, I know who this person is, okay? I actually don't know who they are, but I know that this is the same person that was just visiting me because I gave them this particular cookie value. Okay, now let's say that I eventually log in, okay? So my browser is going to keep sending this cookie, okay? And so eventually I'll log in. And then Google will first check my password and they'll say, okay, I know who this user is. I know that their password is correct. And I have a cookie. I see that they sent this cookie value with them. Okay, so now I can merge those two things. So I know that this cookie now belongs to this user. I actually know everything the person did before they logged in, I could have tracked. Okay, I didn't know who they were, but I was just writing it down with this cookie value. The person with this cookie value did this, 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 and this. Then they logged in. Now I know it's Jeremy Clark. So I know Jeremy Clark did all these past actions. So even things that you did before you logged in can be attached to your identity once you log in because the cookies allow you to trace that information. Okay, and then it will merge it. And most websites, like we mentioned, will allow you to have more than one active session because most people have more than one device. And so that's the sort of, but older websites might kick you off of your old cookie once you log in with the new cookie. Okay, is there questions about the mechanics of this or corner cases or anything? Okay.
So say,
Yeah.
what happens when someone gets hold of the cookie?
Okay, so when you get rid of a cookie, it can happen either client side or server side. Okay, so let's start with the client side. So let's say I can go in at any time, I can delete all my cookies. Then my browser will stop sending them. So that's all that changes. So when I start sending them, I won't send a cookie value along with it. So then the website will receive it and it won't know who I am anymore. And probably the very first thing it will do is try and set me a new cookie.
So I want to understand, somewhere in July, I installed a software, and
Yep.
a hacker got access to my computer. I started doing a lot of things. So I just wanted to understand the process. How was that person able to enter my Facebook account without getting any authentication?
Right, so sorry, what exactly did you do before they got access?
The software?
Yeah.
It was like a free software.
Yeah.
And all of a sudden my laptop started slowing down. I thought it was just normal.
Right.
And all of a sudden one Sunday my account was gone.
Okay, got it. So it could have happened, I guess, one of two ways. So one way is it could have, if it had root access to your computer, then it could have just actually went into the cookie jar and pulled your cookie out and then logged in. So that would be step one. The other way it could do it was with a keystroke logger. So eventually you would have went to facebook.com, you would have typed it in, and then it would have recorded your password, then sent it home, and then the person logged in as you. So
I stored a lot of passwords.
yeah. So anyways, and it could have read it out of your password manager to like, there's a couple different ways. Yeah, that would work. Okay. So users can control their cookie jar. They can't really control what a website does, but they have full control over your cookie jar. So if at any time you want to delete cookies, you can delete them. If you want to block cookies of certain kind, you can block all cookies, you can block certain types of cookies, and so you can do whatever you want. So the browser will give you some control over it. Things like Ghostery are actually meant to give you more control or expose like the control that you get. So common things would be, we haven't really defined what a third-party cookie is, but a cookie party is, it's the slide's wrong, or it's missing. It's basically a cookie that's being set by a website that's different than what the cookie's for. So if we go back to this, mail.google.com told my browser to make a cookie for mail.google.com. The cookie language, the way that you specify cookies, you'll see in a second, it's flexible enough that I could, as mail.google.com, ask for a cookie for facebook.com. Then my browser might, if it accepts it, then every time I go to Facebook, it's going to send this cookie value, okay? So normally your browser's not, now it's like very commonplace, like it would be hard to get your browser to accept it, but it's going to be hard for you to accept a domain that's completely different than the domain that you're visiting that's trying to set the cookie, okay? Within subdomains, it gets more complicated, and we'll review those rules.
Professor, is there a way that a cookie can follow me if I set no third-party cookie? Because
Yeah.
to follow,
Yeah, so it can. Yeah. So basically, there would have to be a relationship between the website that you're visiting and the tracker.
Okay.
But that's actually very common. It doesn't, like, turning off third-party cookies doesn't really protect you as much as you would think. Usually what websites will do is, let's say let's say you're going to Concordia and Google's paying Concordia to track you, okay? Then what will happen is, if with a third-party cookie, Concordia would just set a cookie for Google, and then every time you go back to Google, it would know who you are, kind of thing, right? Now what it will do is it will open up an iframe for Google, and then Google itself, through that iframe, will set the cookie. And so it ends up being more or less the same thing. So everyone turned off third-party cookies, but you can absolutely go to one website and have a cookie set for a different website. It's just because that website is loading a frame that contains the other website on your behalf. Yeah. So it doesn't really control much. But okay, if you clear cookies, it empties your cookie jar. Okay, you can clear it on a site-by-site basis, or you can clear the whole thing. Then you just don't send the cookies anymore. When you go to the websites, they'll start setting it again, and then you'll sort of start with kind of like a fresh identity until you log in. Once you log in, then it will say, oh, this person I've been talking to forever, right? they're the same person that I had this other cookie for, and it all gets merged anyways, okay? So if you empty your cookie jar and never log in again, then you can sort of have a fresh identity, okay? But as soon as you log in, then it can collapse those two histories together. A way to start with a fresh cookie jar other than deleting your cookie jar is to use private browsing mode. Okay, so that's actually all private browsing mode is. It's a really fancy, it sounds really fancy. More or less all it does is it opens up a new browser with an empty cookie jar. Okay, and then you start collecting cookies in that mode. Once you close the browser, then it deletes all those cookies. If you open a new window, you get an empty cookie jar. So it's a good way, because sometimes you want to debug things, like something's like not working, like your login loops, or like, and so you can use private browser mode just to like open a new session where there's no cookies. If you delete all your cookies, it's going to be a pain because it's going to sign you out of like basically every website that you're on, right? And so it's annoying to do. So this is a way if you just want to debug things that you think are like kind of cookie related. Okay, most cookies you can, on the browser side, you can define a policy. So you can say, I want all my browser, I want to clear all my cookies forever. Okay, so that would be like emptying yours. You can have a policy that every time you close your browser window, it clears them. Okay, so your cookies only last for as long as the browser session, and then once you close it, then it clears it client side. Or with private browser mode, you get a fresh cookie jar. Yeah. Okay. Now the website itself also can put some expiration information in. Okay. So the website itself can put in an expiration date. It's actually required, but it can pick like a date far into the future if it wants it to stay alive. So cookies will eventually expire. That's set by the server, and the server can also ask that a cookie get deleted upon browser close. So Gmail could say, I want this cookie, I want you to delete this cookie once the browser closes. Okay, so Gmail can control that. The user could also set that policy. So it's either one can set a policy like that. Users, you can use a browser extension that will show you more about the cookies and where they're coming from and things like that. So that's the point of the assignment that you're doing. And then on the server side, servers can also clear cookies anytime they want, but you have no idea when they're doing it. Or even if you click the sign out button, it doesn't necessarily, you think it would clear it server side. They might continue to use it to track you. They might just say, okay, now if this person shows up again with the same cookie, I'm not going to assume that they're logged in. I'm going to ask them for a username and password, okay? But I'm certainly hanging on to this cookie because I want to track them, right? So just because you sign out, it doesn't mean that the server is necessarily going to clear the cookie. Okay, it could just use it for tracking, but it generally is going to make you authenticate again. There's the keep me logged in. This is again is a server side feature, so it's up to the website to define. Question? Yeah.
Yeah, you said the server could still keep the cookie
Yeah.
after you sign out.
Right.
Then my question I asked earlier, you said that the solution was you sign out and then when you start a fresh browser, it gives you a new cookie. But if you sign out of that previous cookie and the attacker still has that previous cookie, but you said it's still used by the server, can they still sign in with that cookie down?
Right.
Even though you sign out, can they still use that cookie to still?
Yeah. Okay. So let's just be like very explicit. So there's me and you. You'll be the user. I'll be your attacker. Okay. So you're logged in. You get cookie A. I steal cookie A. So now both of us have cookie A. You go in with cookie A and say, I want to sign out. Okay. So now we still both have cookie A. The website still probably remembers cookie A. And so let's say you're doing stuff on the website that you don't have to be signed in for, like you're looking at news articles or whatever. If I'm doing the same kind of thing, the website's thinking that my actions are your actions. Okay, so it's conflating our two actions. So there's a kind of attack there where I can do stuff and the website's going to think you're me, right? That I'm you. But then as soon as either of us try to do an action that requires authentication, then it's going to ask for a username password. So then you're going to be able to put in a username, password, and log in. I'm not going to be able to do that because I don't know your username, password. Yeah. So that's basically it. So the website could use it to trace it. The attacker then could create false traces for you, but they couldn't do anything that would require authentication. Cool. Okay. Okay. So this is what cookies actually look like. I can I'll try and show it to you rather than just the slide. So you go to a website. So TSN's good because it's a very spammy website. Okay, so there's a bunch of cookies here you can see that are, there's a bunch of domains that are trying to set cookies for this, okay? So there's TSN itself. There's some things like this looks like an ad agency, pubmatic.com. There's things like Crave, which is affiliated with TSN, like the same parent company. CTV owns both of those two things. Google, like I mentioned in the video, it's on like, I forget what the percentage is, but a high percentage of websites use some sort of Google servers and things like that, okay? So these are all the things that are trying to set cookies. Now you'll notice that actually, TSN sets a bunch of cookies, but none of the other websites are actually setting any cookies when I visit the website. So why is that?
Maybe they don't know from me.
Okay, not that.
You didn't accept cookies when you visit the site.
Okay, so let's say it's that. Why?
They ask you because of the.
Who's they?
The site ask you.
Okay, so not that. If I could guess. So it actually is my browser settings. Okay, so I have browser settings that are very strict. Okay, and all of these, notice these are third-party sites. Okay, these are all cookies that are coming from other things. Okay, so if I unclick prevent cross-site tracking, then this should help. I don't know if I have to close it to save it. This is the main setting, but there might be other settings that are kind of. Okay, so now first off, you might notice it's loading a lot more cookies. So it might be able to sense that this is turned off, and then because of JavaScript, it's loading more websites and things like that. But now you can see that some of these third-party sites are setting cookies. Okay, so this ad site is setting them, and yeah. Okay, and then what a cookie looks like is basically, this is kind of small, but I'll just say it fast, and then it's in slides as well. So there's the name, which is the key. There's the value that's being set. There's a description of the domain, and it's going to be, there's actually two domains that are involved. So there's the domain I was visiting when this cookie was set, and then the cookie itself is allowed to specify a domain when it should be sent back. And they may be the same thing. The most natural cases, they're the same thing, but there is some degree of freedom in terms of variance. There's also a path that would say only send it if it's like /index.html or something like that. Like it goes along this path. There's a session flag. There's an expiry date. There's two security flags, HTTP only and secure. And then there's a newer flag called same site. Okay. So I just want to check one thing. Okay. Okay, so the things that we saw here are basically content that TSN weaved in. I did go to TSN and I asked for the website. TSN chose to put this stuff there, okay? So that stuff is there by choice of TSN, okay? They're choosing to put that into their website, okay? And a lot of times if you're like, hey, I wish I had Google admin tools, like web tools, what Google will tell you is, here's some JavaScript, copy and paste it in your website anywhere you want, and then you're done. But what it's doing is it's loading an iframe, and then the iframe is loading actually Google, and then Google's setting cookies once you ping the server at that particular address, okay? So it just sort of automates everything, okay? But anyways, these are all things that are there because TSN chose them to be there. The name field is chosen by the server, so it's the key value, and the server chooses, it can call it whatever it wants. The value is also server chosen, and usually it's a random number because it's a session ID. So a session ID implies that it's being used to log you in, like the way that we described. Now, one thing we didn't talk about is, are there other things to do with cookies other than keeping you logged in? Okay, and the answer is yes. You can use cookies. Anything you want to remember about a user, you can use a cookie for. Okay, so for example, I go to Concordia's website. It shows me the website in French. I want the English version, so I click the English button on the website. Okay, now tomorrow I come back to Concordia. Is it in French or English? Usually in English, right? How did it remember that? It used a cookie. Okay, is this a secure cookie? Like, is there a security thing? Not really. Okay, so in that case, the cookie would basically just say language English, like would be the value. It's not like a secret, a hash, or a random number, or things like that. Okay, so the values themselves, if it's some sort of session ID, then it will be like a password looking thing. And if it's some like kind of like sometimes they're human readable, so you can look at them. Like there's one here that looks like some JSON or something, like success, blah, blah, blah. So it's more a configuration kind of thing. Okay, so this is the website that's setting the cookie, okay? And the way that we'll talk about it a little bit next class, but the way these cookies are being set is they're not true third-party cookies in the sense that TSN is asking my browser to remember a cookie for gum.criteo.com. What's happening here probably is that gum.criteo.com is opening up an iframe inside the TSN website, and then the content of that iframe is asking me to set the cookie. Okay, so the browser's showing it to me like, hey, you just download this website. Here's all the other websites that came down with it. They're all the ones that want to set cookies. Okay. Anyways, let's say that www.tsn.ca sets a cookie. Okay. It can also say whether you should send it if you go to images.tsn.ca. It might say that's okay with me because it's part of my domain, or it might say, no, like this cookie is only for tsn.ca, it's not for any subdomain, okay? So that's what this field is for, and there's a slide in a second that will go through all the different variations of it, okay? The path you can kind of ignore. Oh yeah, okay. So, .tsn.ca, okay, let's start with this one. So, this cookie is set for www.tsn.ca. That will only get returned if you go to exactly www.tsn.ca / whatever you want. Okay, the / is in the path. Okay, but as long as you have to go to that exact domain, then that cookie will come back. If you have .tsn.ca, it will go to any subdomain, including TSN.ca itself. So you go to tsn.ca, the cookie will go. You go to www.tsn.ca, the cookie will go. You go to images.tsn.ca, then the cookie will go. Okay? So if you want to include all subdomains, you put a dot. A dot is like a wildcard. Then this one is a subdomain. Remember, we were on tsn.ca, and it's saying, actually send it to every subdomain of me, www.tsn.ca, but because there's a dot here, it can be a subdomain of that subdomain. So it could be www.2.www.tsn.ca. This is almost for sure a mistake, okay? Like there's no reason for this dot to be there because probably people aren't going to create subdomains under www. Normally, if you create a subdomain, you don't put it under the www, which is itself a subdomain. So this is probably just a programmer mistake, and you see it all the time, okay? And if you go on like a lot of like Stack Exchange and things like that, Stack Overflow, you go to like those websites and people are like, oh, my cookies aren't working. And then they're like, oh, just put a dot in front of all your cookies. And then that's what people do to try and fix things because it gets it to be the most permissive sharing of cookies. Okay, so the path, you don't really see it. It's usually, as long as you're going to the domain the cookie's going. But if you want to restrict it to only like /wiki/English/ then you send it. You can use the path constraint to do that. You have the expiry date. So your browser will first check the expiry before it copy and pastes the cookie into the header. And if it's past the expiry date, then it will forget it. Okay. If it says session, that means that when the browser closes, the browser forgets it. And if it has a date, then it will use the date itself. Okay. So you can see some variants here. Some of them are set. I made this slide last year, so they're set pretty far into the future, like 2025. So that would be multiple years. And then others are session cookies, and then some of them are like closer in date. The cookie's the size. It's basically just a function of how long is the name and the value string. That's more or less the size of it. And then you have some security flags. So the two that we'll talk about are secure and HTTP only. So secure means that you should only send this cookie over HTTPS. Okay? So if I'm Google, all my web services are in HTTPS anyways, right? So the cookie, if I scope the cookie to myself, I know it's only going to be set over HTTPS. But what if there's some weird scenario, or maybe there's a man in the middle and they're doing like a downgrade attack or something like that? Just for extra security, I can ask the browser, also double check that it's going over HTTPS. If you see it not going over HTTPS, then don't send it. Okay, so the browser will do that double check for you. So normally you should see this flag set for all cookies because almost the entire web runs this way. Why developers don't use it more, I don't know. It's probably because it's just backwards compatibility, or they don't really understand it, or whatever. Yeah, but it probably would be safe for like basically to have this check mark everywhere. Okay, the next one's HTTP only. It's kind of a weird name because you think it has to do with the distinction between HTTP and HTTPS. It doesn't, okay? So it has to do with the distinction between HTTPS requests that are created by the browser because you went on a website and the website told you to load something, or you typed in, an actual URL, those kinds of things, okay? So that's world A. World B are all the requests that are created from JavaScript. So once you have JavaScript running, it can also open up connections and ask for requests. The browser's not creating those requests. When a website receives a request, it knows whether it got it from the browser or if it got it through JavaScript. They look different. It uses a slightly different protocol. So what you can do is you can say, hey, this cookie, you should only send it if the user is initiating the request through the browser itself. Okay? And what this stops is it stops some attacks like cross-site request forgeries and things where you need to use JavaScript and then you want the user's cookie to be put in the JavaScript, and then you're going to try and attack it based on what goes across the wire. So that's why that flag exists. So we'll see some of these attacks later, and then you can think about what the purpose of this flag is. But basically, it's going to kill it. Now, if you're going to a website, it's browser initiated, and it's over HTTPS, and this flag is set, the cookie still goes. Okay? So don't read HTTP only as HTTP as opposed to HTTPS. It will go over HTTP. It will go over HTTPS. The distinction here is whether the browser is sending it or whether some JavaScript is sending it. Okay. And then just to show you sort of what we saw live, I should actually, before I forget, let me change this setting back. So cross-site tracking, this is like the newest, not necessarily the newest version, but this is sort of what Safari does. Is they used to have a bunch of different things like third-party cookies and other kinds of stuff. So now they just have one privacy thing that collapses a bunch of different privacy features into one. So when you click this box, it prevents actual third-party cookies, but it also prevents a lot of cookies like this that are being weaved in through iframes and things like that. And then it will send do not track headers, I believe, and there's a bunch of different things that it will do. But anyways, it just gives you one global setting. And the behavior you can expect is that when this check mark is checked, anything that matches the domain that you're visiting, so I went to tsn.ca, it's allowed to set cookies. And anything that doesn't match will not be allowed to set a cookie. Okay? And then if I go and I turn it off, then all of a sudden I'll have a bunch of cookies. I might have more websites that are trying to set cookies, and then I'll have actual cookies being set for sites that aren't the site that I'm visiting. Okay, so I went to tsn.ca, but Yahoo is setting some cookies for this website. As a result of visiting this website is a better way of phrasing it. Okay, the last little bit is just a little bit of red tape about going back to this. So like, what are you allowed and not allowed to do? So you're allowed to like have your cookies mismatch slightly who's setting it. So you have the website that's setting it, and you have what you put in the cookie. You're allowed a little bit of differences between them. Okay, so I'll just go through them quickly. It's kind of tedious, but anyways. So let's assume that the website I'm going to is encs.concordia.ca. So that's the website I'm on. It's setting a cookie, and it's going to ask my browser to remember cookies. And in the cookie itself, it's allowed to say, when should you send this cookie back to me? Okay? So it's always, more or less, it's always going to send it if you go back to the exact domain, encs.concordia.ca. But if you go back to different variations on the domain, then it may or may not send it, and the website's allowed to choose that, okay? So it could say, send it only to encs.concordia.ca. So that's called an exact match, and that's a valid thing to ask for. So if I go then to encs.concordia.ca, it will send the cookie. If I go to, for example, images.concordia.ca, the cookie will not go. If I go to just concordia.ca, okay, so that's a super domain, the cookie's also not going to go because it's scoped to exactly encs.concordia.ca. So any subdomain of it, it won't go. Any super domain of it, it won't go either. Okay, and if I go to a completely different domain like canada.ca, it should be obvious that the cookie's not going to go in that case. The next thing I can do is I can put a dot between the encs.concordia.ca. What that says is exactly encs.concordia.ca or any subdomain of it. Okay, so encs.concordia.ca is an exact match, that's fine. Images.encs.concordia.ca is a subdomain, so that's fine. Concordia.ca is a super domain, okay, so it won't go. Images.concordia, not .encs.concordia, but just .concordia, that's a sibling of me, so it's not going to go in that particular case, and it's a completely different domain, it won't go. I can move up a domain if I want. So if I'm at encs.concordia.ca setting the cookie, I'm allowed to set cookies for all of concordia.ca, okay? In that case, encs.concordia.ca, any subdomain of it, any sibling domain, the parent domain, the cookie's going to be global, basically, as long as I'm in the website. The only thing it won't go is if I go to a completely different domain, then it's not going to go with it, okay? So this is the most general way of doing it. And like I say, a lot of people that don't understand this, developers, they'll just set this as the default because it's the most permissive and it will be accepted in the most places. The most chances of seeing the cookie from whatever domain you're in. Now, could you go right up to .ca? And so the answer is no, and this is just a policy decision. Okay, so there's no technical limitation, like technically Concordia.ca is a subdomain of .ca, the top level domain, but we're just, the browser policy doesn't allow you to do it. The reason is that your cookie will go to like if you did .com, it would go to basically every website, okay? It's hard to imagine a use case for that. You could imagine massive privacy violations because then you could track users amongst all sorts of domains and things like that. So it's just straight up not allowed. And then the third thing is if I'm at encs.concordia.ca, am I allowed to set a cookie for a completely different domain than me? So can I set a cookie for Canada.ca? So this is what a third-party cookie is by definition. And I put the X there because now most browsers just disallow it. But it technically, it could be possible if your browser allows you, or if you went in and overrided that setting, okay? But this is more, this is more of a browser decision just to not allow third-party cookies, because they're almost always used for tracking and they're almost never used for like a good purpose. The only legitimate purpose for this would be something like, actually, if we go back to the website we were on, let's say you're at tsn.ca and crave.ca is like, they're both owned by the same company, then you might want to like, you know, set cookies for each other. But anyways. Okay, then we can think about paths as well. So the path basically has to be an exact match. So if I set the domain to say encs.ca and I set the path to /tilde-clark, that's my website. Then if the user goes to Manon's website, then the cookie will not go with it because the path doesn't match. The path is it's never used, like almost never that I've seen, but anyways. Okay, so those are all the different kinds of permutations that are involved in that. Okay, so it's 4 o'clock. Why don't we take a break for 10 minutes and then we'll pick up the rest. Okay, we'll get started again. Okay, so just to sort of summarize the cookie policies that we've seen, I just want to introduce this idea of an origin because it will become relevant next class also when we talk about the same origin. It has a very similar like kind of breakdown, but let's say I asked tsn.ca for something. tsn.ca is kind of like the origin. It's the origin of all of these cookies, okay? So then if I create requests from tsn.ca, like say it says, here's 4 iframes I want you to load these 4 iframes. One to Google, one to Snapchat, one to DoubleClick, one to Twitter. Okay, it can do that. Then what will happen is I'll create all 4 of these requests. I'll go in my cookie jar, but now because my request is going to google.com, whatever cookie I put in is Google's cookie. Okay, so I'm not putting TSN's cookie into my response to Google. This request, the fact that TSN asked me to open up this iframe is sort of irrelevant. Okay, it's now an iframe. It's going to Google, and so that's a communication between me and Google. Okay, so whatever cookies I have for Google, those are going to get included. If I don't have any cookies for Snapchat, then it won't include any cookies. It will just send the request. Okay. So basically, when I create a bunch of requests, my browser basically says, okay, I see where this is going. Do I have any cookies that match it? So yes, no, no, yes. Then I do a quick check of the expiration date. Is it expired? No. Okay, that's fine. And then I'll look at the flags as well. So, oh no, this is actually going over HTTP, but it's marked secure, so then I can't send it or whatever, okay? So the browser does these 3 checks. If everything checks out, then it puts the cookie in and then it gets sent off, okay? Now I keep saying the cookie. Normally, like if I go to TSN, you saw all those cookies, like I'm sending like 50 cookies, okay? So like you're sending a boatload of cookies back and forth for all sorts of different things. Okay, and then third-party tracking, just to we sort of talked around how it works, but just so you see it explicitly on a slide, this is more or less how it works. So I go to lululemon.com and I say, give me index.html, it gives me index.html, okay? I see a shirt, I like the shirt, I'm looking at that page, whatever, okay? Now, let's assume that Lululemon has a relationship with an ad agency. So they give out this idea of me of tracking users and things like that. So let's say it's called Agile 1 or whatever. So what Lululemon will put into their website is they'll put some JavaScript and they'll just paste it into all their websites. So every time I load their website, so I load this website, I'm looking at this shirt, What it's going to do is the JavaScript is going to open up a new connection to agile1.com, to that domain. It'll be in an iframe or whatever. And because Lululemon can choose where to send me on that website, this is up to the website itself. So it's up to the ad agencies and the websites to like figure out how they want to do this. But what Lululemon might do is they might pass along what item I'm looking at. Okay, so they see me, I'm looking at 9483, and so they just pass that information in the URL that's getting sent off to this ad agency. So now the ad agency knows that a user who's on Lululemon is looking at this particular shirt, okay? They don't necessarily know who I am. Depends if I'm logged in and what my past history is, but let's assume, like we normally do, that this is a fresh browser. Just turn it on for the first time, or I'm doing this in private browsing mode. So what Agile 1 will do is they'll run their JavaScript or whatever, but then they'll also throw a cookie in. So they'll say, okay, I'm giving you user ID 55, all right? Then what will happen is I'll go to some like completely unrelated website. So I'll go over to cbc.ca, okay? And CBC will also have a relationship with the exact same ad agency, okay? And so what will happen is I'll be reading an article, or I'll ask CBC to load me an article. And so it will bring down the article. CBC will also direct my browser to connect to Agile 1 and run some JavaScript. So I'll do that. And as soon as I make that connection, I send along that user ID 55. Okay? So now Agile 1 sitting there saying, hey, I just saw this user before. They were on Lululemon. They were looking at this exact shirt, right? And so now CBC is coming to me and they're saying, I want you to put a banner ad on CBC for whatever you want. Like, it's your choice. You can show the user anything. And so the ad agency is thinking, well, they were just looking at the shirt. Why don't I just show them an ad for the exact shirt that they were looking for? Okay. And because of cookies, I know what that looks like. So when I send that request, that cookie gets added in, it matches the previous cookie. And so then I get something like this. Okay, and so you may have had that experience. Actually, just today we were watching YouTube and some product that I was looking at, like before that was the ad that was playing on YouTube or whatever. Okay, so that's how all of this is possible. Usually it's not Agile 1, it would be Google themselves or Facebook or something like that, but it could be any, and a lot of these websites will work with more than one ad agency as well. So as long as there's some overlap between them, okay? Now, does this mean that you can get tracked to every website? No. Okay, so only websites that would have that relationship with the ad company. Okay, so the ad company is the thing that allows a cookie to sort of travel from one website to another because they have that ad agency in common. Okay, so if you set up a website and there's no third-party relationships possible on your website, then this type of thing isn't possible.
Well, there are also databases that cross all the agencies. And
Right.
so they basically try to identify you by your move of mouse or type of browsing. And in that way, they are able to know that are you. And the scary thing is with WhatsApp, you say something.
Right.
They also do the same.
Yeah, exactly. So cookies aren't the only way to track a user. So we talked a few lectures ago when we talked about Tor, we talked about these super cookies of like asking the browser for what fonts do you have, and everyone's sort of a little bit unique. And so you could use that as a cookie. You could use mouse movements if you have permission to read it, or if you have the sufficient JavaScript. Yeah, any kind of voice authentication, that type of thing. Okay. Okay, so you might say, okay, this is terrible. Okay, we shouldn't allow this, right? Why do we allow Agile 1 to track users across totally different websites? What's an easy fix? How do we fix this problem if we don't like it? Okay, so we just block third-party tracking cookies. Okay, so we allow you to load the iframe, but once you load an iframe, then you're not going to be able to load it. Okay. All right, so then the follow-up question is there any useful purpose for this? Is there any useful reason why a website would want to load a totally different domain on it and allow cookies to go back and forth between that domain? Okay.
Because they are outsourcing some of their stuff from their website to other third parties.
Okay, so advertising is one. Anything else?
They also increase the user experience.
Okay, yeah, so there's lots of things like that. So it's not all nefarious. Yeah.
all the charts and graphs about
User preferences.
what's trending, what majority of users are going through and all that.
Right. Yeah, exactly. So from this is why Lululemon would do it with Google or whatever, is because they're giving them all sorts of fine-grained information. They're like, this is the exact search term that someone searched for, and then they clicked on this. And by the way, we know that they're a female between this age group and things like that, like because they have an account with us, and at least that's what they say in their account. So that's why these websites want to use them for sure, is that they get a bunch of information as a result. And then what Google does is they get the ability to track people, which is useful, and they can sell it to other people as well. Yeah. Okay, but in terms of this functionality, it's actually useful for all sorts of things. So when you do this type of thing, and it's like not for like tracking or nefarious uses, we call it a cross-site request. So that's the sort of technical term for what's happening here. So this is a bad example, a privacy invasive example of cross-site requests, but cross-site requests aren't necessarily bad. So one example would be like, the example we usually always use is like the Facebook like button. I know I don't even use Facebook anymore, and so it's kind of a stale example, but it used to be the case that you would read a news article, there would be like a like button, you could click it, and then it might repost the article on your timeline. Your friends could see it, and then it could tell you things like, oh, 6 of your friends like this article. Okay? All right. So how does that actually work? Like how does CBC know that you have 4 friends that liked this particular article? Okay? And so it works through this cross-site request. And the answer to the question actually is that CBC doesn't know how many of your friends like it. Okay? What CBC does is it draws a box and it says, Facebook, you put whatever you want in the box. This is what the user's looking at. Facebook then puts in that like they fill in that box with your friends and things like that. So that information, it doesn't go back to CBC at all. Okay? CBC can't click the like button for you. Otherwise, they would make you like all their articles, right? So you can't reach inside the box. So reaching inside the box from outside of it, that's what we'll talk about next class. That's the same origin policy. But here in terms of cookies, I'll send a request for an article from CBC. CBC will say, okay, I have this user. They want to read this article. I'm going to create an iframe, and I'm going to give it to Facebook. Facebook can put it whatever they want in the iframe. Now, if the user's logged into Facebook when this happens, then the browser is going to see this request go out to Facebook, and they're going to say, I know who that is. Facebook, I have a cookie for it. It matches. They'll drop the user's cookie in. Okay? So if Facebook gets... there's a user, they're on cbc.ca. If CBC decides to pass it in, they know what article they're looking at, and they also know who you are. They know this is Jeremy Clark coming to the website because they're logged in to Facebook. Okay, so that's what Facebook sees. Then what Facebook will do is when they fill in that box that they're allowed to fill in, then they'll say, okay, I'll give you a like button, and if you click the like button, it will like literally update my Facebook account. Okay, because Facebook is filling this in, they can do that. Okay, so even though from the user's perspective you see CBC and you see a like button, right? The cross-site request is what's allowing you that when you click that like button on CBC's website, that it actually changes something on Facebook's website. Okay, that's what this cross-site request is allowing. And so if you change your cookie policy to not allow this third-party cross-site requests, then all that kind of functionality would break. Okay, so Facebook's like, I know who this person is, and then they'll give them some JavaScript for the like button. You click on it. When the article says 7 of your friends liked it, that's because Facebook filled that in. So Facebook first saw that you were logged in. They know who you are. They know who your friends are. They're like, how many of his friends like the article? Oh, it's 7. And then they write that into the website. Okay, CBC can't see it. Even though it looks like it's on CBC's webpage, it's actually inside an iframe, and Facebook is the only thing that controls what's in that iframe, and they're the only ones that can see what's in the iframe. So CBC can't see it. Okay, so your browser basically weaves this content together. It looks like a unified website, but the functionality is provided by different sites. Okay, so anyway, all of this is possible because of cookies. Now, if this kind of thing is possible, we know that that enables third-party tracking. So that's kind of a bad thing. The other thing it can lead to is attacks. Okay, so there's one like class of attack that was very popular. It's become less popular now, called cross-site request forgery. Okay, so cross-site requests are not bad; they're good. Okay, but forgery is the bad thing that happens. Okay, so lots of websites nowadays they use what's called this RESTful architecture. So let me just... I'll go to Bing because Safari knows what Google is and it won't show me the actual URLs. Okay. So what I did is I went to a search engine, bing.com. I put in a search term, CF Montreal. I went to the second page of results. Okay, so that's where I am. That's the website I'm on. I'm on page 2 of the results for this particular search term. Okay, now what I want to do is I want to click on this number 3. So I want to go to the third page. Okay, when I go to the third page, what will happen? Okay, it's going to show me the third page of the results or whatever. Now, how does the website remember that I was on the second page, and how does it remember that what I'm looking for is CF Montreal?
Because it's related to your session. There are more variables that the server has about you.
Okay. So there's 2 ways that it could work. So the first way is, it sounds like the cookie thing I asked you before. How does Gmail remember that you're on the inbox? Okay. So what the server can say is, I know who this person is. They have a unique cookie, and I'm just going to record it. So their last search term was CF Montreal. They were on page 1, then they went to page 2. Okay. And so if I see a request for page 3, then I can go, I'll see it come in with the cookie value. I'll go into my database and I'll say, okay, the person with this cookie was looking at CF Montreal, and then that's how I'll figure it out. Okay. Now there's one problem with this, which is just I have to remember a lot of information. I have millions of users, and I have to write down all of them and their full history, and then I have to try and figure out, I have to devote computation to going and getting that record and looking it up when the user comes back. Okay? So there's an alternative way of doing it. Does anyone know? Okay, so you can put it in the URL itself. So if you go look at the URL has the search term in the URL. It will somewhere have what page you're on. I don't know exactly how to parse this out, but it will be there. And then there's a bunch of other kinds of things. Similarly, right now when I click on that number 3, it goes to a URL. That's what happens. I just request what's at this URL. So what Bing has done is they programmed that URL to be that the URL to have the search term CF Montreal in it, and to have the page 3 of the results in that URL. Okay, so when I click it, basically the state, like what I'm searching for, what page I'm on, all of that stuff, it's being carried by the URL itself. Okay, so now the advantage of this is that Bing doesn't have to remember anything. Okay, they don't know where I was or what my search term was or anything like that. Okay, they just look at the URL and they know what I want to do. Okay. Another advantage or disadvantage of this is if I copy and paste that URL and emailed it to you and you click the link, you would open up automatically to have searched for this result and be on page 2, just the same as me. Okay, so everything is sort of contained in the URL itself. So we call this RESTful, and it's very popular now. It's basically the main way. Almost every major website works this way now. Okay, so cross-site request forgeries will take advantage of this. Okay, so the way it works is basically I start by luring a user to my bad website. Okay, how do I get someone to come to my bad website? I have to use phishing or domain like typo squatting, like I need some mechanism, okay? So if you never go to a bad domain, then you will never be vulnerable to this attack, okay? So the attack is premised on the fact that somehow I get you to click a bad link and you go to my website. Now, generally, if you click on a bad link, it usually doesn't break things, right? Like that's the whole idea of the web anyway, is that you could actually click on any link that's dangerous and it's not going to like break other websites. It's not going to break your browser. It's not going to break your operating system. Now there's exploits, right, that run in the wild that do make things break, okay? But short of there being any exploit, if all the like policies are being followed and everything is working correctly, there should be no danger actually going to a bad website, okay? But in this case, there will be one. So I lure you to my bad website, and I send you down the website, index.html, and I control this HTML, right? So I can ask it to do anything I want, okay? So inside of the HTML, what I'll say is, I'll say, go ask for a request from bank.com. It doesn't matter how I do it. I could open an iframe. I could just ask for an image that has this particular URL. And then eventually when an image doesn't come down, it will kind of break the website. But it doesn't matter. The browser just says, okay, I need to request this URL from this website. Okay? So I just put it in the HTML somewhere. And let's say my request looks like this. So I say, go to bank.com and ask for /account transfer 100 from Alice to Eve. Okay? Now, if the bank is implementing this RESTful architecture, then that might be how they do bank transfers. There's some page immediately before it where they filled in all the details of the transaction, and then instead of the bank.com remembering all that information, they just stuff it into the URL. They click the button, and then it sends the URL with that information in it. Okay. Now the only final problem is, well, the bank.com isn't going to do it unless if I'm logged in. Okay. But let's say that I'm logged in anyways. If I'm logged in anyways, then I have a cookie. That's what it means to be logged in. So I have an active cookie. This is a website that's doing a cross-site request. So my browser will throw in my cookie to any outgoing connection, outgoing request to bank.com. And so it will toss it into this request as well. So from the bank's perspective, all they'll get is they'll get a request. It has the right cookie. It looks in its like cookie table of logged in users, and it sees that I'm logged in and this is indeed my right cookie. And then it sees this instruction to do this thing, and then it will do it. Okay? Then it will send back whatever, and then it's up to the website. It doesn't. The website can display it or not display it or throw an error. It doesn't matter at that point. The money's gone anyways. The website doesn't care. Okay? And so the money would get transferred out. Okay? So anyway, so this is like a very serious problem. It's also something that's like not easy, particularly easy to fix. One fix would be that you just turn off cross-site requests, period. Okay? You can do that, but then you're going to break all third-party advertising. Maybe that's a good thing. It's a good thing for me and you. It's maybe a bad thing for Facebook and a bad thing for the websites that benefit from it. But it's also going to turn off like the Facebook like button and basically any interactions between different websites and things like that. Okay, so it's not considered a really viable solution. So that browser policy is going to stay the way it is. Okay, so what we need instead is we need some way to kind of work around this particular issue. So there is a common way that's done. You whether you realize it or not, you actually saw it when we looked at this string. So you can see the search term is here. The pages will be encoded elsewhere. And then there's things like this. Okay? CVID equals like big blah, 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 blah. Okay? What these things are basically the cookie values. Okay? So the main way to solve this is you say, what the bank will do is it will say, okay, we use RESTful. So it's true, we will do a bank transfer that looks like this, okay? And we are going to check the cookies, and we're going to check that the cookies are in our cookie table. But we're going to add one further requirement. The requirement is that when you use one of these URLs, you have to put the cookie value in the URL as well, okay? So now I'm doing a third check, which is I'm checking, I check that the string is fine. Then I check that the cookie value that was appended in the header matches the thing that's in my table. And then I check that the cookie at the end of the URL matches the one that's in the header of the URL and thus matches the one that's in my table. Okay? So basically I'm looking for the same cookie to be in three places. It needs to be in the header, it needs to be in the URL, and it needs to also be in my cookie table. Okay? Now, why does this solve the problem? So let's think through it two ways. Let's think through it from the legitimate bank's perspective, then we'll think about it from the attacker's perspective. Okay? From the legitimate bank's perspective, what will happen is I'll go to the bank and say, log me in. Okay? And the bank will say, okay, I see your cookie. I see my cookie table. I see that you are who you say you are and that you're logged in. Okay? And I'm sending down websites to you, and all the links on the website I'm giving to you, they're all programmed with these RESTful instructions. Okay? And because I know the cookie and I'm giving you the URLs, I can put your cookie value at the end of the URLs. That's no problem for me. I know what your cookie value is. Okay? So I can do that. Okay? So the bank is capable of creating URLs like this. Okay? Now, what about the attacker? Is the attacker able to create a URL like this? Okay? So the attacker doesn't know what your cookie is. They lure you to your website. They're relying on the fact that you're logged into the bank, but your browser's the thing that's sticking this cookie value into this request. Okay? So your browser puts it in. Okay? Evil.com never learns what this value is. It never sees it. Okay? This is a communication between the user and bank.com. The fact they were able to program this string. Okay? So evil.com basically has control over the value of this string, but they have no control over what this value is. They don't see it. The only thing they know is that the browser will put it in if the user's logged in. That's all they know. Okay? So because of that, they're not able to stick it at the end of the URL. Okay, they don't know the value, so they can't stick it at the end of the URL. And if they don't stick it at the end of the URL, then the bank will ignore it. Okay, so anyway, so that's the common way to solve cross-site request forgeries, but it requires extra engineering, and you have to stick these cookie values everywhere. Okay, so that's why URLs look kind of weird. Now, one danger of this is you have to be really careful when you copy and paste URLs to your friends. Right? Because you could be sending your session IDs or your cookies with them, and if they really knew what they were doing, they might be able to pull it out of the URL and open a session in your name. Okay? So just a word of warning. But yeah. Yeah.
So we don't know it's possible to get cookies from a separate website. Like an attacker can say, get this cookie from this victim, right?
By getting a cookie, you mean learning what cookie it was, or getting the website to give them a cookie?
Like getting the website that the victim is on to get the cookie that they are currently using, like get the cookie that's from the victim. Is it possible to make that cookie specific, like get this cookie from this URL or get this cookie from, or is it going to dump all the cookies?
Yeah. So if you're on my bad website, all I can do is send you to URLs. That's the power I have. So I can make your browser go to a URL. And that's the only power I have. Now, I can know that when you go to this URL, this bank is going to set a cookie if you don't have it, or it's going to ask you for your cookie if you do have it. So I know that information, like, because I went to the bank and that's how it behaved with me. But I can't control anything about what cookies you send, you don't send, what you ask, what you get, or anything like that. All I can do is I can point you at a URL and make you at least send a message and get a response back from that URL. That's the only thing I can control.
I thought it was worked hand in hand with cross-site scripting. So like you inject the JavaScript code to the website that the victim is on, and you can extract information based on the website that the victim is on.
Okay. So that's a separate thing as well. So if I get JavaScript running on, so it's sort of the flip scenario. So here you're on my bad website, evil.com. Okay. And I'm opening an iframe to bank.com, which is a good website. Okay, so it's the outer website is a bad website, and the inner site is a good website, but it's isolated from the bad site because it's in this iframe. Okay, so the bad site can't see what's happening in the good site. Okay, if this doesn't make sense to you, we'll cover it next lecture. Okay, but with cross-site scripting, it's the opposite. So you have a good website, like the user actually goes to bank.com, and it's the good website. Now the adversary has bad JavaScript that's running on the good website. So the outer website is good, but then the inner website is bad, or like the thing that's inside of the website is bad, right? And if it's not isolated, because JavaScript isn't, so that's what the same origin policy will dictate, then the bad script can read things of the outer website. Or it is the outer website for all effective purposes, so it can do whatever the outer website can do. So if the outer website can ask for cookies, then it can ask for cookies, like it can do whatever it wants, kind of thing. Yeah, and so you can use cross-site scripting to do session hijacking. That's the ultimate goal here is to do session hijacking, right? So this is one way of doing session hijacking. Cross-site scripting would be a different way of doing it. And then there's things like clickjacking and a couple other things we'll talk about doing it. So all of them you can think of as just different approaches that basically get me to hijack your session, more or less. Yeah. Okay. Other questions? And I'll show you some like crazy attacks just so that you appreciate how complicated that do blend cross-site request forgery and cross-site scripting as well. Yeah. Okay, so in summary, the cookie policy of browsers, it's a good thing because it lets you, stay logged into websites. It lets you personalize the websites and it remembers them. And then cross-site requests aren't inherently bad. Okay, so they can be good. They can do things like give you a Facebook like button or things like that. The cons is that it makes session hijacking is now a threat that you have to take seriously, and your session ID, your cookie value, is more or less equivalent to your password. Okay, it might be slightly less than powerful than stealing your password, but I can do a lot if I can steal your session ID. And so the difference is just that it's up to the website. So if a website treats a cookie exactly the same as a password, then they're effectively the same, except for the session ID will eventually expire. And then the website might limit, with a cookie, you're only allowed to do certain things, but with a password, then you're allowed to do more advanced things like change your email address or reset the account or delete it or that type of thing. From a privacy perspective, you can abuse the cookie policy to track users across multiple different websites. And that's it. Okay, any final questions about cookies? All right, good. So good luck with your assignment and your projects. And yeah, I'll see you all next week.